Hi guys, welcome to my channel. In this video we are going to solve the questions about the study course, and we are going to learn how to draw shear and the moment diagrams. So let's solve the question. But before we solve the question, if you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong and something that bothers you, please comment, and I'm going to try to make the videos and the channel better for you. So let's solve the question. First, I'm going to start to draw the free body diagrams of the beam. Now you can see on the screen. Okay, so for I'm going to start to solve from this part. Yeah, for example, it's going to be something like that. This is point B, and this is point C, and this is point C is roller, and point B is a pin. Okay, so and I have a moment at this direction as 800 pound-feet, and I have a distributed load 150 multiplied 6 is equal to 900 as pound. Okay, 900 pound. I have a force here, and this is By and this is Bx. Okay, so now let's take the moment with respect to B and determine the Cy, and then we are going to write the total of Y equation and determine By. So total moment at B is equal to 0. Sorry, I'm gonna write the length here. I forgot to write it. Minus 800. This side is positive, so this direction, and minus 900 multiplied 3, right? And we just have a Cy multiplied 6 equal to 0. Yeah, from this equation, I'm going to obtain Cy equal to 583.33 pound. This is the Cy. So let's write the total of Y equation also for to determine the By. And total of Y is equal to 0. And this is 900 minus 583.33 pound. Sorry, I don't need to write pound. And minus By equal to 0. From this equation, By will be equal to 316.67 pounds. Okay, now also we obtain the By. So let's solve the second part, this part. Okay, so I'm going to draw the shear diagram, the free body diagram of this part. It's going to be something like that. For example, this is fixed. I have Ay, I have Ax, and also I have Ma. Okay, I have a moment here, and this is going to be point B. If it is at this direction, sorry, it's from this section. Okay, from B to C. If the B is upper direction, for the A to B, it's going to be a downward direction. So this is going to be By 316.67, right? And I have a force here at 8 feet. This is 8 feet, and this is 4 feet, and this is 700 pound. Okay, so now I'm going to take the moment with respect to that point A, and I'm going to obtain the Ma. Okay, so total moment at A equal to 0. It's going to be minus 700 multiplied 8 and minus 316.67 multiplied 12 and plus Ma equal to 0. And Ma will be equal to 9,400 pound-feet. Now I obtained also a moment at A, so let's determine the Ay. Ax is equal to 0 because there is no any forces at the x direction. Total Fy equal to 0. And from here I'm going to obtain as 700 minus plus 316.67 minus Ay equal to 0, and I'm going to obtain AY as equal to 1016.67 pound. Now we obtain the all shears and also the moment at A. So let's draw the shear diagram. For example, this is the point A, and this is, for example, B, and this is C, this is A, B, and C. Okay, this is the shear diagram, and this is the moment diagram. So for shear diagram, I'm going to take a little up because it's going to be better to show you. For shear diagram, at A, I have an force, shear force as upper direction as 1016.67. Okay, 1000. Sorry, yeah, it's going to be. Oh, I'm not good at drawing. Yes, this is better. So this is 1016.67. Okay, now I have a force at here, but we can write it directly as we have a force as shear force 1017. Okay, just direct write as 1017, and I'm going to continue with the same amount until I reach the point of where the force applied. Okay, until the 8 feet distance. So for example, this is 8 feet distance and the force applied at this point, and I'm going to decrease. Sorry, it won't get 0. I'm going to decrease as 700. Okay, so it's going to, for example, 300. Now I'm at B, and this is 317. Sorry, 317, because a force applied as 700. And here, look at here, I have a distributed load, and due to this distributed load, I'm going to decrease as triangular, because the distributed load it affects and in the shear as triangular, and it's going to be something like that. The amount of that distributed load, 150 multiplied 6 equal to 900, right? So I'm going to decrease as 900, and I'm going to reach the point as 587. Sorry, 583. Sorry. And this is positive, and this is negative. Okay. So now I have a moment also. Let's draw the moment diagram. I have a moment also 9,400. For example, this is 9,400. And I'm going to increase this amount of area. Now you can see the first one, and this is the 8 feet. Okay, this is the 4 feet, and this is going to be equal to, when I increase at this amount of area, I'm going to reach the point. For example, this is the point 1267, and I'm going to increase again at this amount of area, this small rectangular area. Okay, for example, this is now you can see this small area, and it's going to reach the point 0, but it's not going to be directly linear, because the curve of this the slope of this both, it's going to be different. And I'm going to increase as parabolic at this amount of area, as parabolic. Okay, so how it's going to be increased? 317 multiplied this length. What is this length? X. So what is this one? What is this one? This is 6 minus x. So x over 6 minus x equal to 317 over 583. Okay, and x will be equal to 2.1. And when I write here as x 2.1 and multiply 317, so 2.1 multiplied 317 over 2. Okay, and I'm going to reach this point. For example, this point. What is this point? 334. This is the point of where the local minimum and maximum, okay, when the curve changes. So when the slope changes from positive to negative. So for this one, and then I'm going to decrease at this amount of area. And when I decrease at this amount of area, I'm going to reach at the point 800. Okay. For example, it's going to be again parabolic. For example, this is 800. It's okay now. The moment diagram also drawn for this question. This was 800. Why? Because look at here. We have 800 pound-feet moment at the end of the roller support. So we have to reach that point. Normally, if there were no any forces, sorry, if there were no any moments, we will just come to stay at zero, because that was a roller, so there will be no any moments. So now for the first question, I guess you understand how we're going to draw it. So let's solve the second question. In the second question, now you can see we have two supports, and we have here as a cantilever load, and we have a moment here, and we have here as AY, because this is pin, and AX, and we have a BY. And so now let's solve the question. I'm going to draw the free body diagram of the question here. This is AY, AX, 40 multiplied 8, 320. Yeah, for example, this is, sorry, BY. It's going to be at midpoint of 8 meter, 320. This is 4 meter, and this is 4 meter. And I have a force here, 20 kilonewton. I have a moment here, 150 kilonewton meter. Okay, so now when I take the moment with respect to A, when I take the moment with respect to A, I'm going to obtain the BY. So let's take the moment with respect to A, moment at A equal to 0. And for example, minus 320 multiplied 4. Sorry. It's going to be, look at here, I'm going to show you, multiplied 4, moments arm is 4. And also I have a 20 kilonewton multiplied, this is 3 meter. So minus 20 kilonewton multiplied 11, and minus 150 kilonewton meter as the moment. And I have a BY that's going to turn the beam to counterclockwise direction. So BY multiplied 8 equal to 0. And BY equal to 206.25 kilonewton as the force. Now we got the BY. So when I write the total Fy equation equal to 0, and I'm gonna obtain also AY. So let's write it, 320. Now you can see, for example, no, sorry. 320 minus, minus BY. What is BY? 206.25 and plus 20 and minus AY equal to 0. Okay, and AY from this equation we are going to obtain as 133.75 kilonewton. Okay, this is going to be AY. Now we obtain the both shear force, and once again AX also we have, but AX is equal to 0 because there's no for horizontal forces. So now we obtain the forces. So let's draw the shear diagram. Now this is going to be shear diagram, and this is going to be moment diagram. For the first part, for the shear diagram, it's going to be something like that. For example, this is point A, and this is B. This is A, and this is B. So I'm going to increase at amount of 133.75. Okay, and I'm going to decrease as triangular, because look at here. If you have a distributed load, this is distributed load. This is distributed load. If you have a distributed load, the shear diagram, it's going to be as a triangular, okay? So it's going to be something like that. For example, this is 320, the value of distributed load. It's going to decrease as 320, and it's going to reach the point of 186.25, right? So 320 minus 133.75 equal to 186.25. So now it's okay. I got this point. And for now, I'm going to look at here. There is no, now we have a force actually here, sorry. We have a force actually at By. At By, it's going to affect at the upper direction, 206.25. When it try to increase at 206, and it's going to reach the point of, the point of 20, okay? Yeah, from here when applied, 206.25, and it's going to reach at the point 20. For example, this is 20 kilonewton. Yeah, sorry, I forgot to write sometimes. So it's going to reach at this point. Okay, this is 20, and it's going to continue with the 20. And when it reached the point of cantilever, okay, the point of cantilever from this point, the 20, it's going to apply as downward direction, and it's going to be closed, okay? So it's positive, negative, and positive. Now we have the shear force diagram. So let's draw the moment diagram also. We have a zero moment here because look at here. This is a pin, so at pin there is no any moment. I'm going to increase at this amount of area, and it's going to be parabolic, because if the shear diagram is parabolic, sorry, if the shear diagram is triangular, the moment diagram is going to be parabolic. And if it is parabolic, it's going to be the third degree, okay? So look at here, for this one, it's going to increase at this amount of area. At this amount of area, and this is going to be x, and this is 8 minus x, this is 3 meter, okay? And x is equal to 3.344 meter, okay? When I multiplied 133.75, okay, when I take the area of this, now I gave you the value of x, you are going to obtain the increase of the moment here, okay, the amount of this area. So, and this is going to be 223.61, and then I'm going to decrease at this amount of area. When I increase at this amount of area, I'm going to obtain the point 220. For example, this is 220, okay, because I have to decrease at this amount of area, and then I'm going to increase at this amount of area, and this is going to be 20 multiplied 3, 60. When I reach the 60, okay, 220 minus 60 is going to 150, because look at here, there is a 150 kilonewton meter as the moment at the last part of, sorry, at the end of the beam. So you cannot directly go to zero, and so you are going to reach the 150 kilonewton meter as the moment at the end of the beam. So now I guess you understand how you are going to solve and draw the moment and the shear force diagrams. And this is the x, also this length, okay, and this is 3 meter. So now the question is solved. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, please warn me. I'm going to try to fix it. Please comment. If you anything you want, anything you wish, please comment. I'm going to care and try to make the questions better. Okay? See you for the next question.